Block 1. Mass Illusion Revealed. Forget everything you think you know about mass. Forget the neat diagrams in your high school science textbook showing little billiard balls orbiting a neutron. Forget the idea that you are a solid, stable collection of matter. Because today, we are going to expose one of the biggest, most profound, and most beautiful lies in all of physics. It's a lie of omission, an oversimplification so vast that it has shaped our entire perception of reality. The astounding truth is this: nearly all of you isn't there, at least not in the way you think. The overwhelming majority of your mass, the very stuff that gives you weight and substance, the quality that keeps you anchored to this planet, is not matter at all. It's a ghost, a phantom. It is the raw, untamed energy of a fundamental force of nature, churning violently inside every single atom of your body. Let's start with what we're taught. We learn that the world is made of atoms. Atoms are made of a nucleus, containing protons and neutrons and tiny electrons buzzing around the outside. Simple enough. We're told that your mass is just the sum total of all these little particles. Add up all the protons, all the neutrons, all the electrons, and you get you. It makes intuitive sense. If you build a house out of bricks, the weight of the house is the weight of all the bricks. But this is where the grand illusion begins. When physicists finally smashed open protons and neutrons in giant particle accelerators, they found they were made of even smaller, more fundamental particles called quarks. Specifically, a proton is made of 2 up quarks and 1 down quark. A neutron is 1 up and 2 downs. So, the new logic should be simple, right? The mass of a proton is just the mass of its 3 quarks added together. But when scientists measured the mass of the up and down quarks, they discovered something that should have been impossible. The masses of those 3 quarks combined only accounted for about 1% of the proton's total mass. Let that sink in for a moment. 99% of the mass was simply missing. It was a mystery that struck at the very heart of our understanding of existence. Where was all that missing mass coming from? Now, you might be thinking, wait a minute, I've heard of the Higgs boson, the God particle. Isn't that what gives everything mass? And you're partially right. The Higgs field is like a cosmic molasses that permeates all of space. As fundamental particles, like quarks and electrons, move through this field, they experience a drag, a resistance to acceleration. That resistance is what we perceive as their rest mass. The Higgs mechanism is responsible for giving the quarks their tiny, tiny sliver of mass. But it does absolutely nothing to explain the other 99%. The Higgs boson explains the mass of the bricks, but it doesn't explain why the house weighs 100 times more than the sum of its bricks. The answer to this profound riddle isn't a particle at all. It's a force, the most powerful force in the known universe, the strong nuclear force. This is where Albert Einstein's iconic equation, E equals mc squared, enters the story, but not in the way you might expect. We usually associate it with nuclear bombs or the sun, where a tiny amount of mass is converted to a colossal amount of energy. But the equation is a two-way street. It doesn't just say mass can become energy, it says energy can and does become mass. Mass is simply a highly concentrated, stable form of energy. Think of it like this. Mass is the universe's way of storing energy in a compact physical form. The strong nuclear force is the mechanism that binds quarks together inside protons and neutrons. But it doesn't do it gently. It's a seething, chaotic, incredibly energetic process. The energy involved in this binding process is so immense that, thanks to E equals mc squared, it contributes a staggering amount of mass to the system. This isn't binding energy in the way we think of a nucleus, where binding the protons and neutrons together actually decrease the total mass slightly. This is different. This is the energy of the system. Imagine 3 quarks inside a proton. They are not still. They are careening around at nearly the speed of light. They have an incredible amount of kinetic energy, the energy of motion. On top of that, the gluon field, the manifestation of the strong force that glues them together, is thrumming with an unbelievable amount of potential energy. It's this combined kinetic and potential energy, this pure, violent internal dynamism, that makes up the missing 99%. Your mass isn't a static property. It is the measure of the ceaseless, violent energy raging inside every proton and neutron that constitutes your being. So, when you step on a scale, the number you see is not primarily measuring the matter you're made of. It's measuring the raw, concentrated force holding that matter together. You are not a collection of particles. You are a symphony of pure, unadulterated energy masterfully contained in a quantum dance. And that dance, as we're about to see, is more violent than you can possibly imagine. Universe's violent force. So, we've established that almost all of your substance is not matter, but the energy of the strong nuclear force. But what does that actually mean? What does this force look like, and why do we describe it as the universe's most violent? To understand that, we have to shrink ourselves down and journey into the heart of a single proton, a space less than a femtometer across, a millionth of a billionth of a meter. What we find there is not a tidy solar system of 3 quarks in peaceful orbit. What we find is a maelstrom, a chaotic, bubbling quantum soup where the laws of our everyday world completely break down. This is the domain of the strong force, and it is governed by particles called gluons. As their name suggests, gluons are the glue that binds quarks together. They are the force carriers, constantly zipping back and forth between the quarks, transmitting the strong force. The way they do this is through a property called color charge, which has nothing to do with visual color. It's just a label for a type of charge that quarks and gluons carry, much like protons and electrons carry positive and negative electric charge. There are 3 types of color charge: red, green, and blue, and their corresponding anticolors. The rule of the strong force is that any bound particle must be color neutral. So inside a proton, you'll always find 1 red, 1 green, and 1 blue quark, which together make white or neutral. When a gluon travels from one quark to another, it actually carries color charge with it, changing the color of the quarks it interacts with. A red quark emits a gluon and turns green, while a green quark absorbs that same gluon and turns red. This exchange happens at an unimaginable rate, billions of times every microsecond. It's a frantic, non-stop exchange of energy and information that creates an incredibly powerful field of force. This force has a bizarre and unique property that makes it unlike anything else in nature. It gets stronger with distance. This is called color confinement. Think about gravity or electromagnetism. The farther you get from the source, the weaker the force becomes. The strong force does the exact opposite. Imagine 2 quarks connected by a cosmic rubber band. When they are close together, the band is slack, and they can jiggle around relatively freely. But if you try to pull them apart, the band stretches, and the force pulling them back together becomes immense, growing stronger and stronger the farther you pull. The energy you pour into the system by trying to separate them just gets stored in the gluon field, in that rubber band. If you were to pull with enough force, with enough energy, something incredible happens. The rubber band doesn't just snap. It can't. The energy in the field becomes so concentrated that it reaches a critical point where, thanks once again to E equals mc squared, that energy spontaneously converts into matter. A new quark and a new antiquark pop into existence out of pure energy, one latching on to each of the original quarks. You don't end up with two free quarks. You end up with two new pairs of bound quarks. This is why we have never ever seen a single isolated quark in nature. They are eternally confined, prisoners of the universe's most violent and unbreakable force. But the story gets even stranger. The inside of a proton isn't just the three valence quarks we started with and the gluons zipping between them. This superheated, high-energy environment is a perfect cauldron for quantum fluctuations. The vacuum of space inside that proton is not empty. It's a roiling sea of virtual particles. Pairs of quarks and antiquarks and countless gluons are constantly popping in and out of existence, living for just a fraction of a second before annihilating each other. This seething quark-gluon plasma is a microscopic echo of the state of the entire universe in its very first moments after the Big Bang. For the first microsecond of its life, the entire cosmos was a single unified soup of quarks and gluons, exactly like the one inside every proton today. So, what does this all mean for you? It means that the solid, stable reality you perceive is a magnificent illusion. You are not a static object. You are a dynamic, energetic system, a collection of trillions upon trillions of tiny, contained firestorms, each one a relic of creation itself. The feeling of solidarity when you tap your desk is not matter pushing against matter. It's the electromagnetic force field of your hand repelling the force field of the desk. And the mass that gives that interaction meaning is generated by the violent internal energy of the strong nuclear force. You are a walking, talking manifestation of E equals mc squared. 99% of what you call you is the pure, raw energy of a force so powerful it forges reality itself. The universe isn't just out there. A piece of its most primal, most violent, and most creative state is raging inside of you, right now. You are not just in the universe is, quite literally, in you.